Okay, we're going to look at this exam question which looks at current in a parallel circuit, and I'm going to also talk about current in a series circuit as well as a comparison. We have here a circuit with parallel bulbs, and you'll say here that they are identical lamps. That means that they have the same resistance. So the reading on this ammeter is 186 milliamps. Now, let's just look at what the electrons are going to do. The electrons are going to go down this wire, and then when they get to this point here, they are going to split. And some of them are going to go this way, and some of them are going to go this way. Now, they were split according to the resistance that they find down each route. And because P and Q are identical lamps, it means they've got identical resistance. So if they've got identical resistance, the pathways for the electrons going either way number 1 or number 2, will be identical. So the same number of electrons will be going each route. If P had a much larger resistance than Q, then more electrons would go along Q. And so because they're identical, they have exactly the same number of electrons. And remember, the current is the number of electrons per second. So that's the first thing to say. So we know that whatever happens, P and Q will be equal. And then we need to think about what the total current is. Now, if the electrons that go along here, come up here, the electrons have gone through that lamp, come here, they re-meet here. So you're going to have the total current. So the point here and here are going to be the same. And so we know that all of the electrons together give a current of 186 milliamps. And so because half the electrons went to P, half the electrons went to Q, but the total current is 186, it's 186 divided by 2, which is 0.03. So the answer here is that both P and Q would have 0.093. In series, if I did have a series circuit, the current is the same everywhere. So if you had an ammeter there and an ammeter there, the current would be the same, or an ammeter there, the current would be the same all the way through. But with a parallel circuit, the currents add up to form the total current for each of the routes it can take. So the second question here is, one of the lamps breaks and is not replaced. Which statement about the current in the other lamp is true? Well, now, let's say that this is the one that's broken. We actually have all the current going through P. And we know that the whole current is 186, and so the answer here is 186 milliamps.